Right. Good afternoon. My name is Soto, and I'm here with Joe Zadeh, and we're going to talk about profiling VIP accounts access patterns in user-centric data streams. This is sort of a research that we've been doing the last months or so, and it comes from a background of us working before at UBA companies. We are former Caspita employees, and then we worked at Splunk for a little bit, then went to Jask, and now Joe is a core light. So we've been told we only have 20 minutes, so this might go a little bit fast. So we can skip this. So this is what is a VIP account? Let's go and start from there. A VIP account is any privileged account on a system or application. Examples of this, we have domain admins, root backup accounts, DVAs, and it depends of what your schema obviously sets up as a VIP, and we can go a little more in detail. I'm a person with a heavy Windows background, did over 10 years of Windows engineering, lots of GPOs, OUs, and Windows hardening. What we're going to see here, and this is part of what we're trying to accomplish, is basically profile VIP accounts based on patterns of access. And the challenge is, how can you profile this account with large amounts of data and try to make an accurate assertion of if this is a VIP account, and two, if it is compromised. So very quickly, you need VIP accounts if you have some sort of a hierarchy in a network or an organization. You don't want a flat type of permission schema. That's pretty bad. That would be like going back to peer-to-peer. And it usually is based on the trust hierarchy and privileges to specific resources into or in an organization. Here's an example. Domain administrators, basically they can do pretty much whatever they want to do: install software, reset permissions, create accounts, stop services, shut down, reboot. And same thing with the root accounts. It's basically these accounts have the largest at the top of the privileges. Of course, I know the permissions can go way granular, and I will talk about it a little bit on some experience I have in the field. Here's an example of the schema defining VIP accounts. Obviously, this comes from RBAC, role-based access control, which is sort of a concept. The concept has to be operationalized, and it gets operationalized by using usually a protocol named LDAP. LDAP is basically what allows you to say, okay, this guy can do this, this, and this other guy cannot do that. This account can access this share or this file. This other account cannot. We went through this. Here's an example of, for those of you who have ever done Windows, this is for a system administrator. This is a day-to-day, and if you ever taken the MCSE exams, you're familiar with Contoso, because that's a company that Microsoft usually uses in their labs. So basically, what you have here is a GUI where you can show or create distinct levels of access depending on organizational units, of job tasks or roles within the organization. And then from here, it gets even more complicated. So that basically on a very high overview, you have a directory service. This directory service, the account is checked against it. Then there is authentication, authorization, and then whatever resources this account is allowed to access or to use or execute is granted or denied. I know because of my own experience, that it can get way more complicated. There are super admins, there are OU admins, there are hidden OUs. This happened to me once. I have a background in system engineering, and I was actually trying to set up a product user lab, and the person that was there from the company, which was a big airline, was trying to allow us to basically pull from the LDAP to give access to send email to certain employees. For some reason, this guy, every time he logged in, he couldn't get in. Come to find out that he was an admin, but he was not a super admin. So even him did not have access to certain parts of the schema. So that can happen. You also have service accounts. I have worked a lot with service accounts where you have a machine that's configured with an account that can only send or write data to a specific share, for example, during a specific time, and there's no other type of permissions. That account just exists to do a single or very, very fine-grained function. There's also inter-domain admins or cross-domain trust, which makes it even more complicated. We're not going to address that right now, but we are aware of that. So this research is still in its infancy. So why are we profiling these accounts? We profile these accounts because these accounts are high value. They're constantly targeted, and they provide faster access and path to resources that usually that's where the valuable stuff is for attackers. Intellectual property, software, access to specific services, applications. So this type of accounts are usually targeted, and it's very hard if they are compromised to determine that if the behavior is according to an administrator, or is an administrator that has been compromised. That's the core of the question of what we're trying to do. In order to do that, we decided first, okay, we had to start from certain assumptions, and that's why I brought the RBAC and the Director of Services, and then we'll go into the granular, which is access to specific resources. In our case, we did devices. So here's an example of a tool that can allow you to find your way to, for example, the main admin, which is Bloodhound. It tells you actually how far you are from it. Of course, if you're a pen tester, you know this tool, Mimikatz. There's plenty of impersonation, talking, stealing type of attacks. The most popular being Pass the Hatch, which has been mitigated, but there's still a way to do it with tools such as Mimikatz. And then, of course, phishing. We know of, at least when I was working at a CDN provider, DDoS provider, we had a very notorious case of a media company that was compromised by the administrator being phished, and the administrator had all the passwords in one Excel sheet. I think you probably know what company I'm talking about. Okay. So how can we tell if a BAP account has been compromised? So I'm going to lead Joe now.
All right, thanks, Rod. So I think kind of one of the things we're going to just be describing here in how we sort of built up an algorithm to first kind of give us a data-driven picture of what we think VIP accounts are on sort of Windows, kind of large Windows environments. And the constraint we're working with is we sort of had a real-time only architecture to sort of build out this security analytic. So there's some things we're going to brush under the rug in the interest of time. Basically, if you're curious about kind of the supporting architecture, this is basically built through a Kafka Streams application. And really, the key intuition here is an algorithm. There's a blog post I should have stuck the link to, but if you just Google like JASK VIP accounts, you'll kind of get a sense of sort of the algorithmic steps. So there's two kind of components here. There's fingerprinting, and then there's sort of change point detection. The fingerprinting is done intuitively through just, right now we are kind of using Windows event logs, processing some of these event logs that have username, resource accessed, and timestamp, just that triple. And we sort of build a graph out of these and use basically a collection of features. I was actually looking for the feature vector, and I'm sort of lost some data in kind of moving machines. But basically, there's a feature vector that is described by a few different computations. One of them is PageRank. Some of them are just super intuitive graph things like in degree, out degree. And then there's some more sort of domain-specific context around the feature engineering, which just come talk to me afterwards if you want to get into the details here. Basically, what we're going to be doing here is just using sort of a passive over time statistical computations in a sense to say, like, what are the most interesting nodes in this graph? That's kind of the question we're answering. And I think where I wanted to get to, yeah, so here's kind of the real meat of what we do when we sort of have found some accounts of interest. And this is really based off legal action that was taken against a couple of sysadmins who, there's a very large credit card processing company that you've all used, I'm sure. And what was happening was, this is when we were doing some consulting engagements. This is a couple years ago now, but we were helping build out, like, as a professional services team, a security analytic for lateral movement detection. It's very generic, but what this analytic ended up kind of catching was a couple sysadmins who had extreme deviations in their baseline, and the baseline is basically kind of described by this picture I'll get into in a second. And so what happened was, on the day of termination, the admins access like a huge number of resources, like a disproportionate amount versus what they usually access. That was sort of the key kind of thing the analytic picked up on, and it eventually led to, like, a prosecutable case, at least the piece of data that we sort of help add context to. This is very false positive prone. So if we had to look at a heat map per person, you have the majority of the heat maps, even though they have some change point, they're not that interesting. They're FPs. And so why we started adding that VIP fingerprinting piece is to sort of help us kind of filter out the problem. And also because we're kind of doing this in real time, at least this computation we'll describe with the sort of doing something with this matrix. There's sort of a lightweight constraint where we kind of have to be efficient and in memory and all that stuff. So kind of like just to kind of break down this sort of representation here. I forget the event ID in Windows. It might be 4624, yeah, or like 673 in the old days. But basically, we're kind of just using like kind of Kerberos tickets as a proxy for accessing resources, and what we can kind of do. This is a real simplified picture, but if you took, like, when I was an EMC employee, I kind of made my heat map for a few days, and I would have on any given day resource access when I log into the domain to maybe like 20 to 50 different resources, and so the deeper color just means, like, the more kind of access I'm like it's basically a count. We have a normalized count here because there's some machine learning kind of going on, a light machine learning in the background, but really the key intuition is that, like, I have a matrix that describes behavior, and if I'm doing this in real time, I can use a couple just straightforward, like, kind of vanilla computations that are pretty standard for this problem to describe this whole matrix with a single number. We use an algorithm called SVD. Sometimes, I mean, it's pretty synonymous with PCA if you've ever heard of either of them. Basically, we hit this matrix with one of those algorithms up there. We get a single number to describe the matrix. That's the key kind of intuition here from, like, a analytics computation perspective. And then now this is sort of about change point detection. So when we have a new day, we basically get a new computation. A new. This is the first eigenvalue from PCA. So every day we basically get a new number that describes the matrix and how it changes. And so now once you kind of have these matrices per day, like it's very easy to say like, okay, how do these two things differ? And they differ by, if they differ enough by a heuristic threshold that this is something we've optimized against because we have a lot of heat maps we know are sort of labeled and bad. So we basically kind of build a number here that is a threshold that tells us 95% of the time, these things are good, and every once in a while, 1 out of 1,000, we have something violating this sort of difference in matrices, and we have an anomaly. So that's kind of the simple change point detection. And it's just based off our experience of how we've seen admins' heat maps change in not necessarily lateral movement, which was kind of the initial use case we were targeting, but more just sort of like an insider threat, someone who was let go, and on the last couple days, they just basically just took as much IP as they could and accessed a ton of different resources and servers in the Windows environment. I think we got 2 minutes, so sorry that's kind of rushed, but basically the key intuition, just going back to why we want to do this computation, it's to give us an ability in real time, so that's kind of the constraint why we just have single numbers describing this matrix. In real time, we want to say like, is this person's behavior different from their past behavior? And this is in the context of accounts of importance, or accounts that sort of have a high potential risk. And that's why the fingerprinting step comes in. So if we filter out like the majority of users through kind of this pre-processing kind of graph VIP fingerprinting, this analytic becomes a lot less FP prone. So those are the kind of the two sort of kind of blending two kind of use cases. And I think they're a bit orthogonal. One is kind of identifying accounts of interest, and then the other sort of baselining them with a simple lightweight computation. And I think that's about all we have time for. Questions? This might be, I left JASK a couple months ago. We were working on productionalizing it. I lost visibility in if it's been operationalized in the JASK platform. Is this been operationalized in a tool set, or so there's a couple, there's a pivotal EMC professional services engagement that's about 4 years old, where I first saw this operationalized. It was custom code for specific, it was like for a credit card company essentially. And then we were sort of, the EMC part was really just about building heat maps. So when we started doing the research at JASK, this was more about building up that graph analytic, which is also kind of connected to other things like asset discovery. And JASK has done a lot of that already. So there's pieces of it that are operationalized. I don't have my hands on it all anymore, so I might defer the rest of the question to.
It should be on the pipe for production. It should be on the pipe for production soon. Any other questions? Yeah. Go ahead.
Yeah, that's a super good question. So, one of the things we spend some time on, and there's many analytics.
Okay, so the question was.
Sorry. How do we deal with churn in DH, like heavily churning IPs in a DHCP heavy environment is essentially the question. And we didn't really talk about the asset discovery part of this, but mapping IPs to some sort of stable identity, be it a MAC address or in this case usernames, is sort of another model that we've spent a lot of time on. One of the first things the model does is it tries to get an estimate of, even if we don't have any visibility, even we're not talking to sysadmins, we estimate like what is like how often do IPs churn, and and also just like what are the best data sets to do mapping against IPs. We really tried to replace an IP because it's a bit ephemeral, and when we need to sort of build keys that let us kind of like relate baselines over time. So that's kind of a separate model. There's some blog posts about it on JAST.com, JAST that are, if you Google JAST and asset discovery, you'll kind of get into that. But we have a couple other presentations at DEF CON about that too. But it's basically another model. If I can brush a lot of things under the rug. Other question? So another. One more? Yeah. Yeah, so the question is, admin accounts are sometimes intermittent in nature and periodic. How do you map, sorry, what was the last part? Yeah, so that's part of the problem with this model. I mean, there are quite a bit of FPs for the one prosecutable case I can cite. So it's just kind of this is part of kind of managing the broader context within a SEM and just how we escalate this as part of a bigger ticket. This I would consider, like when we use this for the professional services engagement, this was sort of one piece of context in combination with other alarms that just built a story. And on its own, it's very FP prone.
Right, we did some models in the past where the system administrator will go on vacation, for example, and then it will come back and it will start pushing patches at 2, 3 a.m. and then the alerts weren't all over the place. So yeah, that's a great point. I think we are done. All right, thank you.